Hello everyone, I'm Miss Canal, one of your grade 11 maths teachers. In our previous lesson, we looked at logarithm equation. We're still on logarithm, but we are now going to look at a special type of logarithm. When we're looking at logarithm, the other term that they use to describe logarithm is the common logarithm. In today's lesson, we'd look at the natural logarithm. What is natural logarithm? Before we go on to explain what natural logarithm is, there are some very important terms or abbreviation that we need to use, and we'll look at. One of them is ln. ln. And what is ln? ln is about, or it's an abbreviation to represent natural log. Natural log or logarithm. The second is a letter E, and you could have seen letter E written in textbooks. What is letter E? Letter E is the natural exponent and it's also known as irrational. Remember, we looked at irrational and rational numbers. That means that it values, letter E is equal to 2 point, and it goes on and on and on. That is irrational. The third abbreviation that I'd like us to look at would be a letter X, and that would represent real numbers. Looking at that, I'd also would like to look at an expression or equation that we use in natural logarithm. And it goes e to the power of ln x. ln x, the natural log of any real numbers, is equal to x. This is raised to the power. ln x is equal to x. Now, while looking at that, let's look at the way the common logarithm is expressed. And the common logarithm is written as log base e is equal to ln, and in the common log, we would go log base x. We'll leave it at that, and we'll continue on. Now, having written and trying to understand what it looks like, let me put it in an expression. Supposing I have, right? Supposing I have ln 7.5, and that is equal to a value of 2.0149, and I have e to the power of 2.0149, that is equal to 7.5. Look at the position in which it is sitting. ln 7.5 is actually the result of e to the power of 2.149, right? And ln 7.5 is equal to 2.0149. That's very interesting. We can also now write that the natural log to the power of x implies the same as log base ex. And if we write log base ex, let's take note that the value of e, which is the natural exponent, is approximately 2.718, and it is irrational. It continues on. It is not a real number where we have like 0.25. Let's continue on then and get an example number 2 on natural log. In example number 2, or expression number 2, we'd look at something a bit. If we have s is equal to e is equal to the power of 280, and we have t is equal to e to the power of 300, and we have an expression that is going to be involving s and involving t, and both have e to the power of 280 and 300 respectively, then let's look at the expression. And the expression that is going to be given is ln brackets e s squared t to the power of -1. All of that would equal to 261. The idea here is to write it in the form that everything on the left-hand side is equal to 261. Then let's try to understand that. I need to expand e s squared t -1. So we go ln e is equal to 1. We also have ln s squared is equal to e to the power of 280. And we also have, maybe I'll put it down here, L and T, which is equal to e to the power of 300. Note, I should have written this further. It should equal to 280, and this should equal to 300. If that is correct, then let me substitute this. So that would give me to log ln e. It's a multiplication properties rule. When you're multiplying, what do? You add. All right, so we go plus ln s squared, all of that, to add that onto ln t to the power of -1, all of that would equal to 261. If that is understood, where you have the multiplication and now it's been expanded, let's substitute. ln e is equal to 1. Adding that onto ln s squared. One thing, note that I'll have 2 in front of that, but it's all right. We have 2 is the power property. You multiply that with the value of s. And what is the value of s? That would give you to e to the power of 280. I'll put a grouping symbol there, and you add that. Now note, when you have a plus and a minus, the index law says that if you have a plus and a minus, it is a minus. So instead of writing a plus here, I'm going to write a minus. And now the value of t is actually 300. That also gives you to 261. We're still not too sure about whether that equation is balanced or not. So what do? We simplify. That would give me to 1. Adding that onto 2 times 280 would give me approximately, or I think not approximate, it would give me to 560. And I take that, subtracting 300, that would equal to 261. The sum of 1, leave it, 560 subtracting 300 would give me to 1, adding that onto 260, and that is equal to, oops, that's a 0, that is equal to 261. 1 plus 260 would give me to 261 is equal to 261. I am satisfied that everything on the left-hand side is equal to 261 on the right-hand side. And this brings us to the end of trying to understand what natural logarithm is. And in our next lesson, we would be looking at still a logarithm, but trying to use the usage of the logarithm table. With that, I hope you have enjoyed the lesson. I'll see you in our next lesson. Bye.